the mean. Math is everywhere, y'all.
It's everywhere.
All right, so let's look at a problem. So single, it is what it is. Group, we have to rearrange them, and we have to redo the standard deviation. So, first thing we're going to talk about is how to redo the standard deviation, how to make the standard deviation smaller. So, did this one have directions or not? It said, based on data from the College Board, assume that SAT scores have a normal distribution. So just to get a picture, we have a normal distribution, we have a mean of 1518, and we have a standard deviation of 325. Assume that many samples of size n are taken. So this is if we had single data. So it is what it is. This is individual single data. Now, because this first problem says that we have n equals 100, that's telling me we now have group data. We have a picture of 100 people. So we're telling you to scooch in, so you're no longer 325 pounds. You're going to look smaller. So we have to make you look smaller. So we have to redo your standard deviation. So anytime there's group data, we have to suck in our belly. We got to redo our standard deviation. Now, it says for each problem, find the mean and the standard deviation. Now, for individual data and for group data, if I just have 2 people and I have a ton of people, my mean is still in the middle. I didn't change my mean. I just changed, hey, he was fat and now he looks smaller. So my mean still stayed the same. My standard deviation went from 100, let's say, to 2. So my standard deviation is going to change, but my mean never does. The center of the picture is still going to be the center of the picture. So for this problem, your mean does not change. Your mean is still going to be whatever it was in the middle. I put 100, but it should have been 1518. I'm still stuck on that 100 and 116 problem. My mean is still 1518. Let me put it in red so it matches so you can see where it came from. My mean is still 1518. Now, this is a formula. It's on your formula sheet and we'll talk about it. Your new standard deviation is the old deviation divided by the square root of the size of the group. Your new size is your old size divided by the square root of the size of your group. So, we were 325 pounds divided by the square root of 100 because there's 100 people in the picture. So I did 325 divided by the square root of 100. So if I'm in a picture by myself, I look 325 pounds. But put me in a picture with 100 people and I look 32.5 pounds. You with me? So my mean didn't change, but my standard deviation did because you put me in a group of people with pictures. That's all I want to know in this problem is, what did my new standard deviation become when you squished me up? Let's look at another one. So this is showing if you put 100 people in a picture, your mean didn't change, but I look skinnier. Now, what if you put me in a picture with 2,500 people? I'm going to look even tinier. What is my mean going to be? What is my mean going to be? 1518. My mean ain't going to change. My mean is going to be 1518. My new size is going to be what I was originally. How much did I weigh in that original picture? 325 divided by the square root of 2,500. So 325 is what I was in the original picture. divided by the square root of 2,500. So now, I'm 6.5 pounds. Because you put me in a picture with a lot of people. Yay? What is this standard? Why is the standard deviation in part A different than part B? The more people in the group, the smaller you look. Cool? Now, this one is just saying that if you have one or two people in a picture, you know, if y'all are about the same size, and then I put more people in there, and more people in there, and more people in there, no matter what it looks like in the beginning, it's going to end up looking like, if you put enough people in it, they're all going to look like a normal distribution. So if it's like me and my husband's taller than I am, I mean, even if it's a skewed picture, you know, you and your husband, or if you and your husband are the same height, in the end, if you put enough family members in there, it's going to be a normal distribution. That's what this one's talking about. All right. Oh, I love this problem. Kindergarten desk.
Oh, God.
If you go into a kindergarten classroom and you sit in one of these desk chairs, you know in kindergarten you feel like you sit and your knees are in your mouth. But when you sit in one of these, whoever, you have to do statistical data. How do they know how tall these should be for the average person? They have to measure a bunch of people to figure out. Well, how do they know how big they need to be for little kindergartners? They have to figure out how big they should be. Okay? Now, I know there's some kindergartners that are tall, and I know there's some grown people that are tall and are short and their feet don't reach the ground or whatever. But they have to figure out what the average is. So that's what this problem is about. Designing new desks for 25 kindergartners. They had to get the sitting height, which is from their back of their knee to the ground. They figured out that the kindergartner girls have a normal sitting height that's normally distributed with a mean of 61.2 and a standard deviation of 3.1. So the first thing I'm going to do is draw what they're telling me. We have a normal distribution with a mean of 61.2 and a standard deviation of 3.1. So that's what I got from the first paragraph. Okay? Now, what percent, let me cover this up so I can move it up. What percent of individual kindergartner girls have heights, sitting heights greater than 63? Now, this is individual data. Individual. This is like what we just have been doing for the last 2 class periods. So we have a 63. 63 is to the right because it's bigger. And we want to do greater than. So we're going to go this way. So we're going to do normal, CDF. What is my left? 63. What is my right? 999. What is my mean? 61.2. And what is my standard deviation? 3.1. And by the magic of TV, I already have it written right here. So I did 63, 999, 61.2, and 3.1. So this is exactly like what we've been doing. So 28% of girls are taller than 63. We good? Now, here's the new part. From a randomly selected group of 25 kindergartner girls. When it says a group, that means we're taking a picture of a bunch of people. So we have to redo the standard deviation. So this redo means do your old deviation divided by the square root of the size of the girl. So what was our old deviation? 3.1 divided by the square root of 25, because we got 25 pictures, girls in a picture. So, my new standard deviation is 3.1 divided by the square root of 25, 6.2. Bless you. Okay, we good? So now we're going to do the normal CDF. Everything is going to be the same. My left is the same. My right is the same, my mean is the same, we just gotta use the new standard deviation. So when it's group data, you do the left, the right, the mean, and you gotta do the new standard deviation. Now, y'all, here's what I do. Instead of recalculating that, this is the easier way to do it. Watch this. Oops, I got the wrong button. Here's the easiest way to do it. You take this first problem right here, that part A problem, and I move that part A problem right down here to part B. We'll cover that up right there. Now, all I did was divide this by the square root of 25. You with me? I go to my calculator right here. So when I did part A, so when I typed part A in, I did 63, 999, 61.2, and 3.1. And I got my answer to part A, right? Then when I go in and I do part B, I back that thing up and I do divide by the square root of 25. There's part B. You with me? I am a cheater. I'm proud of it. So all I did was do the divide by the square root of 25. All right. What we will do at the beginning, I'm done with chapter 5. I have one more problem that I'd like to do. I will put it in your notes so that you'll have it to do chapter 5 homework. It's a problem about men and their weight, and about airplanes and their weight. I'll put it in the notes, but I'm done with it. You know enough to do it, but I will do it at the beginning of the class so that you'll have one more. So all we have is chapter 8 to do on Tuesday. Okay? Test is due today. We'll finish up chapter 8 on Tuesday, final exam review on Thursday. And like I said, I'll video the rest of the semester so that you'll have that as well if you need to go back and listen to anything. Jenny, will you shut that for me whenever you feel? Calculators, make sure